10 to 15 minutes. Hope assignment questions all you got. Assignment questions have you taken? Someone reply fast. I uploaded it in the by God. I think it is accessible. And the material also I uploaded it. So let me complete it. Another 4 questions of left out in the assignment. We'll start with the module 2 to complete that questions and come back to one pattern matching algorithm. Very important algorithm is that I will do it when physical classes has started, or else if possible I'll do it in the online only. It takes some time to do that. Okay. So now we'll start with this new concept today, a stack. As we are exact data structures, we are starting it today. It's a general definition that we can see here. Let me record the meeting. 1 minute. Accept it. Yeah, I will share the screen. I will share the screen. Don't worry. I will share. Wait, I'm sharing it. Yes. Now it's visible, I think. Screen. Yes, fine. Okay. So first point, a stack. It's a general definition of stack, which we call it as an ordered list. Stack is a ordered list which have insertions and deletions are made at a single end. So make sure that stack always only one end. So stack will be having a single end ordered list. So insertion as well as a deletion should be done in a single end. Okay. So in stack, the last element, whatever the element that what we have inserted, consider this as a stack. This is a one end we have for insert as well as for delete. So these were the elements that whatever that we are inserting inside the stack. So if the stack, that is in stack, the last element that what we have inserted, the last element what we have inserted is the first one to come out first. The first one to come out. Make sure that, listen carefully, the last element that what we are inserted inside the stack is the element to come out first. This already I have given a brief description when I was describing the syllabus only. So again with the complete description I'm explaining, listen it carefully. So that's why we call that it as a last in first out. That is last in, the element which inserted last in, the same element will come out first out. That is last in first out data structures. Okay, so that's we call it as stack. A standard definition of a stack, it is a common question. An ordered list which can insertion and deletion are both done at the same end called as top of the stack. So generally we call that it as a top of the stack. This we call it as top of stack. So both will be done in a single end. So that is nothing but a top of the stack we call it as. Inserting an element into the stack. So there are some operations that we perform on the stack. So insertion of an element inside to the stack, we call it as push operation. So inserting an element into the stack, we call it as push operation. Removing an element from the stack, we call it as a pop operation. So So push and pop, we should not call it as insert and delete. Insert and delete will be used in a queues. So a general technical words that we use for stacks is push and pop. To insert the element into the stack, we will use it as push. The element want to throw out from the stack, pop. Pushing a element, popping a element, we're going to use in general for a stack operation. Okay, so ADT of stack, that is abstract data type objects, are, whereas in the ADT of the stack, objects are finite ordered list of zero or more elements and functions. So ADT of stack is a objects of a finite ordered list. Objects of a finite ordered list, we call it as an ADT of a stack. What that contains for a stack, epsilon stack, there is an item element and maximum size of the stack. So there will be a element that should be inserted and maximum stack size and a positive integer, whatever that you have to insert along with that index. So stack create, maximum size, an array, an empty stack. This I'll explain with the programming concept. At the time you'll come to know. First you listen how a stack to be created. I think this part is cleared for you people now. How the stack is created, is it cleared? Yes, fine. So here see. Ah, so we want a little empty board. Now we'll take it. So there we should check for three conditions here. So one major condition to insert a data into the stack. So to insert a data into the stack, check the condition where a stack is empty. A first part of that stack, what we have to do, if you want to insert any element into the stack, so check whether stack is empty. A top of a stack we need to check to the maximum size. With functions I will do that. So then is stack empty? If the stack is empty, we can create a element into the stack. We can store some elements inside the stack. If the stack is full, elements cannot be pushed inside the stack. So what is the one more condition? We will do that. Push, check with the empty stack and pop. So if the stack is empty, can we pop any elements? If the stack is empty, is the popping operation can be done? No, right? So at that time, you should put an underflow condition. Here, two conditions are there. Make sure that two conditions are there that we have to take care. One is stack overflow. When stack is full, then stack underflow. When stack is empty, stack overflow condition will be checking for pushing an element into the stack. Stack underflow condition will be checked for whether stack is empty or not to pop the elements from the stack. So this is about a basic operations that what we perform on the stack. And one more time we will tend to check the condition that stack over underflow for displaying the elements of the stack. This is also one operation that how many elements that is present inside the stack we need to check there. Okay, so this about three operations that majorly performed on stacks. Okay, is it cleared? And is the voice is clear? Someone please reply fast. Voice is clear? Yeah, fine. Is the program visible for all of you? Is the program visible? Yeah. Okay. The first part, hash define. So here, hash define stack size is 5. So this is a stack. Consider a stack. Sorry. So 1, 2, 3, 4, and 5. So consider this as a stack. Okay. So of size 5. The size of stack is given it as 5. Now this is a top element pointing to the top of the stack. Sorry. So top will be -1 initially. So top of a stack is equal to -1. So this stack what we have created starts from 0, 1, 2, 3, 4. So totally the maximum size we have taken it as an assumption size of 5. So what are the 3 operations of the stack? Yes, little bit zoom. Yeah, I will do it now. Now is it okay? So in your screen, please you can zoom and see. Okay. So here, what are the operations that we can perform on the stack? Just now I told 3 major operations. Fast reply. Operations performed on stack. Push pop, and more is display. Yeah, good. Push, pop, and display. 3 major operations that we have to perform on the stack. For the push, we have one function here. For the pop, one function, and one display function. Once I'll zoom it, I will show you it. So this is for push. This function is for push, and this function is for pop, and one more function that what we'll use to display the elements of the stack. Okay, so first what we will check is the top of the stack equal to size -1. So now it should be an interactive class. I want the solutions from you people. So now this is the first push function we have. Top of the stack, as I told, when you want to push the element into the stack, we need to check for stack. What is that condition? We need to check for stack overflow or underflow. When you want to insert an element into the stack, it should be a stack overflow or underflow. Yes, overflow. How to check the overflow condition? The top size of that concerned stack we will going to check. Here the size is given 5. Since the array index always it starts from 0, 0, 1, 2, 3 and 4. Array index starts from 0. Top of the stack, that is 5, equal to sorry, just a minute. Yeah, top is equal to stack size minus 1. What is a stack size? Stack size is given 5. 5 minus 1 is 4. What is the current top? What is the current top value assigned there? Not 4. Not 4. Once I mark the arrow to the 4, directly you cannot tell it as 4. Sorry, that is wrong answer. Minus 1. That's Rakshita, it's correct answer. Minus 1. So top, you see at the top of the elements what I have assigned. Initially the top will be minus 1. Okay. So check the condition here. Minus 1 equal to 4. Is minus 1 equal to 4? Condition is false. When condition becomes true, we will going to throw an message that stack overflow element cannot be inserted. Listen carefully. When the top is equal to stack size minus 1, when both are equal, you cannot insert any element into the stack. At that time, only the printf condition will execute. So when the stack is full, at the top and the stack size will be equal. So at that situation, that overflow printf will be printed. If not, we should insert an element into the stack, that is top is equal to top plus 1. So since it is initialized to minus 1, we should go to the first element of the, that is the index, first index of the stack. So for that, s of top is equal to item. Where we item will get, where we will get the item, where we will read that item. So see the another part of the code there. Case number 1, read item, right? So read item, that item you have read. So here you can see here. So case 1 is to 1 to push, 2 to pop, 3 to display, 4 to exit. 4 different switch cases we have taken. So first case number, read item. Once this function is called, this push is a function call. This is called a function definition. This part is called a function definition. Once the definition of that function is called, that item what you have read here, so whatever the item, that's value, whatever that you might have read, for example, some 25, that will be stored into the first index of an array. So again, if you increment the value of, so that is next iteration, again, if you press 1, again, push function is called here. So what is the current top size? What is the top current size? That is a value of top. 0. Yes. Current value of top is 0. 0 equal to 4. Condition is false. Again, read the second element. Okay. Similarly, 30. Increment again. 40. 50. And 60. After inserting this element, after inserting the value 60, what is the current top value? So the top is positioning to this. So by keep on by one incrementing, after inserting the complete values of the stack, now the current value of top is 4. So now you check the condition. Now you press 1 in the main program. Now you press 1 and check the condition. What you will get? Is it possible to insert a element that is a push element into the stack? It is highly impossible, right? Why it is highly impossible there? Why it is not possible? Want it reply fast. Stack overflow. When the stack overflow appears, when the stack overflow appears, I want the condition to be told. Stack is full, correct. Stack size is defined. No, Aryan. Stack size will be predefined. When the stack will become full, there is some condition I have checked. No, what is that condition? When the top and both the size of the stack, yes, 4 equal to 4, correct. When both the top as well as the stack size is equal, that is the top equal to stack size minus 1 equal, at that situation the condition is false, means true, so it will going to display it as stack overflow. If the condition is false, it will come back to this part and execute. When the condition is false, you're going to keep on insert an element inside the stack. So when condition is true, overflow. Okay, so is the push operation cleared for all of you? Is it cleared, Aryan, now? Yeah, only some hardly 20-30 students will be active, I think so. What about the other students? I don't know. Until unless you people are active, I will not share the recording classes. Materials I will share. So simply switch on the system and keep it idle. So as I told, this is a subject will be used for your throughout career, not for the third semester. Make sure that data structures is not the subject for third semester. It is for throughout your software career. It is a very important subject. That's why I'm going very slowly for each and every concept. Just analyze it. 2 minutes, I'll be back. What is that, Fatima? Take your. Who is this useless? Let me check. I'll throw it out. C D E. Okay. So now we'll go with the pop operation. So I don't want this unwanted messages to be put on the chat. Let me know that after the class I will analyze that and I'll throw it back. I don't know who has shared the links to these useless fellows. Okay. So we'll analyze with the IP addresses and I will track it that. Okay, fine. Don't want to waste the class now. So next is the pop operation. So as I told earlier, what the pop operation will do, you have to throw out the elements whatever that has pushed into the stack. So what is the condition to be checked for pop? Yes, reply. What is the condition that we should check for the pop operation? Underflow. How do we check the underflow condition? Stack underflow, yes. How do we check the stack underflow condition? When top equal to minus 1. When top equal to minus 1, not less than minus 1, Rahul Patil, should be equal to minus 1. Okay. So when it is reaches to minus 1, as we know that when it is in minus 1, the stack is underflow. You cannot have any elements there. Means nothing is there. And the stack starts from the index 0 only. When it is having a minus 1, it is an understood part that written minus 1, there is no data elements in the stack. If not, so when it is true, only this statement will be executed. If it is false, so when it is true, return minus 1. When it is false, return s of top minus minus. S of top minus minus means what? What this indicates? S of top minus minus. Which element is popped from the stack? Consider this is a stack we have. What is the element popped from the stack now? As per the regulations of the stack LIFO, what is the element will be removed? Topmost element? Yes. Decrement first element. Once we decrement it, automatically the top of that element is deleted. If you want to print that element, whatever the element is removed there, we can use printf top of minus minus that along with that item. Okay, the topmost element last in first out. Okay, so now again if you put second condition, so 1 is to push, 2 is to pop here. So x is equal to pop. So let me take a little bit talk to this programming code. Yeah, yes, tell me. So when we call this function x is equal to pop, when x is minus 1, we will put it as empty stack. Right? There is no data inside the stack. Else printf that concerned element. When this minus 1 is returned to this function, that value stored in x is minus 1, we will put it as a empty stack. As I told, now if you want to print that element whatever that is popped, if not there is no empty stack, so we will going to print that element that what we are deleting there, that constant element is printed, that is nothing but x. That value will be stored in the x, that element of 60, that the index 4 will be printed onto the output screen. Okay, so again if you call the second function's same pop function again, now what is the element deleted? Miss popped. What is the now element popped in the stack? Yes, 50. The top second. Now the top is pointing to this. So top is pointing to this. This element is popped out of the stack. Right? Similarly, again if you call 40, 30 and 25. After deleting all the popping all the elements from the stack. After popping all the elements of the stack, where the top will be positioned? After popping elements from the stack, where the top will be positioning? Yes, last. Yes, minus 1. That is to underflow of the stack. Is it cleared now? Push and pop, is it cleared? I want reply from all the students. Let me take the random attendance now, then I will explain the what is that, the third function. Yes, fine. So now I request all of you, please type your USN and keep it ready. I will be calling randomly the USN numbers from 1 to 80. Answer to the attendance. USN number 1. Yes, pop operation, I will repeat it. Once I take the attendance, after that I will repeat it. USN 1. 19 CS 001 is absent. 2. 3. USN number 3. Only once the attendance is called. Afterwards, if you put a message also, it will be invalid. USN 003 absent. 04. 5. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37. 38. 26 I marked absent already. 39. 40. 41. USN 040 absent. 41. 42. 43. 44. 45. 46. 47. 48. 49. 50. 51. 52. 53. 53. 54. 55. 56. 57. 58. 59. 60. 059 absent. Okay. 61. 62. 62. 63. 64. 65. 66. 67. 68. 69. 69. 70. 71. 72. 73. 74. 75. 76. 77. 78. 076 is absent, I think. Yes. 79. 79. 079. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90. 91. 91. Who's 91 present? Yes. 92, 93, 94, 95. Please don't put last networks and so on. Only the attendance I want. Okay. Please. 96. In between, don't put. 97, 98, 99, 100, 1, 102, 103, 104, 105, 106. 104 is not that. 7, 8, and 7 is not there. Okay, 9, no, 7 present. Okay, pa. 8, 9, 10, 11, 12, 13, 113, 114, 115, 116, 117. Attendance will be sent in through the message. Please answer properly. 10 minutes already it is wasting for me the attendance. 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132, 133, 134, 135, 136, 137, 138, 139, 140, 141, 142, 143, 144, 145, 146, 146, 147, 148, 149, 150, 151, 151, 152, 153, 154, 155, 153 is not there. 155, 155, 156, 156, 157, 158, 159, 160, 161, 62, 161, 162, 163, 164, 165, 166, 167, 168, 169, 169, 170, okay. 171, 172, 173, 174, 174. Please do not put WhatsApp messages. 174, 175, 176, 177, 176 is done. 177, 178, 179, 180, 77 not there, ma? Yeah, fine. 177 not there. 181, 182, Vivek Sharma, yeah, there. 18 CS 108, Tikshana. Sorry. Tikshana, you please inform Srinidhi sir to add it to your e-governance attendance, ma. 108, 18 CS 108. You please tell to Srinidhi sir to add it in e-governance. Okay. 19 CS 42. Network problem. Always you will get network problems only, man. Okay, please do not disturb in the WhatsApp. Later you can 161 already taken, man. How many times you will tell? Sushmita, I already marked it. How many times you will put the message there? Please don't put the messages. 062. It is already taken. Why I don't know repeatedly people are putting the messages there. Okay, fine. Stop that first. Attendance is closed. So now we'll go with the next function. Okay. So now this display operation, the third case of this function is nothing but display operation. How we're going to display the elements of the stack? How it is possible? So for that purpose, first we need to check with the underflow condition, stack underflow condition, that is -1. That condition we need to check. Once if it is stack underflow, that is the stack is empty, will be returned. If not, the contents of the stack initialize I is equal to 0, I less than equal to top. What is the current top value after popping all the elements? Top is equal to -1 means underflow condition. Under when the stack is in underflow condition, so the elements cannot be present in that. So that's why we are using it as a -1. Okay, you can use -2, -3, and so on. Negative values, once negative values cannot be stored as an index of an array, right? Now, Tej. So that's why we are using it as a negative value there. Okay. So now it is in a -1 state. So when the stack is in -1 state, that is top is equal to -1, the stack is empty, will be displayed onto the output screen. So if not, if any elements is present in the stack, so this for loop is executed. This for loop is executed. So this part of that for loop is executed. Sorry for the interrupt. So what it will display? Consider now we have a stack. So some size with 3, something like stored in a stack. Okay. So 10, 20, and 30. Consider those 3 elements. So at this present, top is pointing to this position initially. It's after loading the complete stack, top is at the top position of the stack. I is equal to 0. So this is a 0th index, first index, second index. I less than top, that is 0 less than top is at second position, less than equal to top, 0 less than equal to top, condition is true. S of I, consider this as S, stack S. S of I, what is S of I now? What is S of I? 30. That current 0th element of the stack 30 will be displayed on the output screen. Then increment the value of I. So once you increment the value of I will point it to here. So now again 1 less than equal to top. What is the value printed now? S of I is after incrementing the I value, the current value 20 will be printed on the screen. So that is first value printed will be 30 on the screen, second value will be 20. So again increment the value of I. So 2 less than equal to 2, condition is true, print this value. 10, again increment the value of I. 3 less than equal to 2, condition is false. Come out of this. So now default the top will go to the -1. Once the top completed, it will going to report it to -1. So the elements inside the stack are negative. That is, no elements present inside the stack. Is it cleared? So what are the three major operations we performed on the stack? This program, again, it will be explained during the third laboratory exercise. Third laboratory exercise is purely based on performing push, pop, and display operation and check whether the given there is inside the elements are palindrome or not. One more condition will be checked over there. So majority of students have not submitted your assessment what I have given in the previous laboratory. So if not done as early as possible, you submit that assessment task assigned for you, execution of the two programs. If you are not having a machines for execution, I given one more task for that. Assignment, you can write first 3 questions and submit it in that task. Okay, I want all 182, it's 180 students should be submitted at least by end of the day today. Okay, at least a program one execution, if not the first 3 questions of the assignment. I don't want the copy paste answers. Write by your own. Material is given. Even for the programs, don't take it from your friends and submit it for the namesake. We will be cross verifying. If I found the same screenshot, that's why we asked it for a screenshot to submit. Same screenshot, if there for the both the USN numbers, we will mark both of them 0 there. Okay. So laboratory, each program 5 marks will be allotted as internal. There is a record marks. So for that purpose, you have to submit it as a recorded there. If you could not do, one more assessment task is given. At least that task has to be completed. Okay. So don't be make it idle. So now you tell, is it cleared this program? Any clarification is there? I want the reply fast. So pop operation, some student they asked again to repeat. So just a minute. The pop, I will clear the board first, then I will reload it again. Just reply fast. Is it cleared? So some student they asked for pop operation. I don't remember the student name. Can you repeat it again? Who is that student asked for pop operation to be repeated? Student who has asked for pop operation, repeat it fast. Who has asked for pop operation? I think, is it cleared or not? I don't know. Yeah. Pranav Kangal. Yes. See to the board. I don't remember the name. Sorry. Here, this pop operation, whatever may be the stack, consider the stack we have. Two elements only I will take 10 and 20. Index starts from 0 and 1. After inserting an element, stack top will be pointing to the current element of the stack, right? So here top equal to minus 1. When the top is equal to minus 1, we will going to return minus 1. That return minus 1 is nothing but there is no elements present in the stack to pop. If not, we will return s of top minus minus. What that s of top minus minus will do? So here you can see this x is equal to pop of x is equal to pop of the function we are calling this pop function. So returning minus 1 when there is no element in the stack, that is when you have returned s of top, that concerned value of the stack will be returned. So last in first out, what is the element will be popped out first, where the top is pointing to. Last in element is nothing but 20. That element 20 will be assigned if there is no underflow of stack. Okay, so now it will check with 20 equal to minus 1. Condition is false, so that item removed from the stack is 20. That 20 will be displayed on the output screen. This is the element removed from the stack. So then it will going to check with the next element. Again, second operation, if you choose pop up, so that element 10 will be thrown onto the output screen. So after completing these two elements popping from the stack, now the current position of the stack is minus 1. So when you execute this at this situation, the stack will be underflow. When there is no elements present in the stack, default stack will be pointing to the minus 1, that is underflow of this stack. Is it clear now? Yes? Yes, fine. Clarification is there, you can ask it in another 5 minutes of time. So you can ask. So if sorry for the interrupt. I think max class will start exactly at 1 o'clock. For the other section, I don't remember what is the section. CRC, please be attentive and active in the class. So in between, it's a lot of problems for you people. Yeah, B and C. USN number 90 to 182. USN number 90 to 182 will be having max class at exactly at 1 to 150. Then you can have a break, I think so. 150 to 250. Yeah. After 250, as usual, classes will be there for you people. This lunch hour, she shifted for that class, only for the today's class, I think so. Okay. So 5 minutes of time, you just analyze the program and tell. So the complete program I am loading there. So just analyze it once and tell me. Any clarifications? You please make it fast. Since if you understand this concept, then only I can do with the lab program. This will wind up the class. You can join for the max class at 1 o'clock. So the 90 to 91 to 182, please go and join to the max class. Thank you. Have a nice day.